Welcome to this course by RouteFabric. In today's session, we're going to cover data science in a very practical sense. We'll be going over a case study. I'm going to keep it abstract so that we really are talking about concepts and steps in the flow of data science. We're not going to be looking at any code during this video, but we will be taking a two-part adventure through a single case study where we go from beginning to end and solve a data science problem for a hypothetical online retailer. So here is the scenario. We have an online retailer that sells products of various kinds, and the online retailer would like to provide product recommendations to its customers so that when someone adds, for example, a tennis ball to their shopping cart, the online retailer's website can suggest that they also consider purchasing, say, a tennis racket. So the problem is that this online retailer sells a great many different kinds of products, and rather than asking humans to go through and decide which products are related to which would be very inefficient and very expensive, this online retailer desires to use data science to solve this problem. So we're going to solve this problem for them. Now this is the 5 stages of the data science process, and we are going to take this scenario through each of these different stages. Starting with capturing and collecting the data, storing it, preparing it for analysis and cleaning it, ensuring that we can use that data to then explore and visualize, understand that data, and then ultimately we're going to use the data to build a model and make some predictions that will benefit the online retailer. Now the problem that we're going to be solving, again, is for this online retailer, there are a number of products. What we want is to find an automated way, an algorithm that we can apply to a set of data that will allow us to establish and then evaluate the strengths of relationships among different products, just so that we can see which ones are related to which other ones. So in this case, we've got a tennis ball and a tennis racket and a microwave. A tennis ball and a tennis racket are, of course, quite closely related in terms of product recommendations, and neither of those things is very related to a microwave. So now we as humans, we can look at these 3 products and we can say, well, it's obvious that tennis balls and tennis rackets are related, and if someone wants to buy a tennis ball, they should probably buy a tennis racket, or at least we could suggest to them that they might like a tennis racket. And of course, that's easy for us to do because we are humans and we are smart. What we're trying to do is find a way to teach a computer how to make a similar decision so that we don't have to have humans to evaluate the relationship among millions of products. If you're a large online retailer, the number of relationships among the number of possible relationships among your millions of products is orders of magnitude larger than what we're looking at here, and would take normal humans many, many years to go through iteratively and do automatically. So we are going to use machines to help us solve this problem, and we're going to use the data science process to provide us a good methodical way to solve for this desired outcome. So we're going to go through each of these 5 stages, starting with the capturing and collecting of data. Now remember that we are an online retailer, and as such, we're a website. We have data about our website and maybe about our customers, as well as the products that we sell. And all of that's going to be digital for us because we live in the year, we live in modern times. So a typical online retailer might have a variety of sources of data. So for example, their e-commerce transaction processor, a big popular example of this might be a processor like Shopify that handles the purchasing and the transactions of actually purchasing and having something shipped to customers. Shopify is one of many platforms that handles those kinds of transactions. And as Shopify does that, Shopify stores a lot of transactional sales data. And if you use Shopify as an online retailer, then you would have access to the data that Shopify is collecting for you. You could access that data because it's being captured for you, as is everything in the digital world. Likewise, as people use your website as an online retailer, you might have analytics tracking software. Most, if not all, modern retailers on the web have analytics watching who goes from what page to what page, how long they spend on various pages, where they are clicking, where they might be hesitating or not paying much attention. There are many different data points that we might use in order to help us to build models and use data to help us solve problems. So that web analytics tracking might be another source of capture for us. We also are going to have customers, and maybe it's in a customer relationship management system, a CRM system, or maybe we just keep our own database of customers, their name, their email address, their shipping information, maybe their phone numbers, what purchases they have purchased in the past, those kinds of things might be stored in a customer database of some sort. Lastly, we have products that we sell. And so we might have a product database that would serve as another source of information from which we could draw in order to explore our data science problems. So these systems, this is a very typical setup of most modern businesses. Everything that we do in business is digital, and because it's digital, it can be captured by the various systems that we use. Now, it is not very often that most of our business operations happen within one system. This is typical where we might use Shopify to handle the shopping transactions. We might use Google Analytics to monitor what's happening on our website. We might have a separate customer system and a separate product system. This is very typical of a modern business because we purchase and use different pieces of software, and they seldom are very compatible and able to be integrated easily. So as we go and contemplate our data science problem, we have capture in all of these various systems, but we do need to pull the data from those various sources into the second stage of our data science process, which is where we store the data. So again, we have our four, in this case, in this example, we have four systems: Shopify, Google Analytics, and then a customer database and a product database. Now, typically, we don't want to be analyzing data straight from, say, the product database or from the Shopify data source. Those systems are dedicated to providing the service that we are using them for. We don't want to distract the customer database server from managing customers and tracking information about customers, and we don't want to slow down our Shopify system by running large queries or doing big analyses with lots of Shopify data. Those are operational systems, and we want to leave them operating efficiently. And so what we typically do as we go to build a set of data that we can use for analysis and for data science is we will pull the data out of each of those individual systems, and we will extract that data into what is often called a data warehouse or a data lake, a big pile of data that we pull data out of. Typically, we in maybe batch files on a nightly basis, we might export the information being captured in those various operational systems, and we will extract them and place them into our data warehouse or our data lake. And this data warehouse is separate from these operational systems. We can use that data without slowing anything else down, and that allows us to use even massive data sets to solve various problems. Now, as you might imagine, the people over at Shopify who design the way that data is stored for Shopify are going to be different than the people over at Google who are deciding how the Google Analytics data is going to be stored. And because those two data sources come from two sets of software that are made by different companies and different people, the data is rarely going to be very compatible. And so often as we assemble a set of data into a data warehouse like this, there's a lot of work that we have to do to arrange and join and make these various disparate data sources compatible with each other. And so this extraction typically involves at least a little bit of cleaning of the data, and sometimes we just have to massage it a little bit in order to ensure that we can join the data together as needed, and that we can run queries, and that the queries will run with some level of efficiency. So the title of this slide is focused on storage, but I have and clean in parentheses, because as we extract these pieces of data from these various data sources, we are typically going to have to do at least a little bit of cleaning to make the data fit together. So that's our second stage in our data science process. We are using our various systems over there on the left to capture and collect the data. And then from those systems, we're going to pull it together into a storage container, data warehouse, or a data lake that we can use to house the data that we will then use for the rest of our data science processes. So during this first part of this two-part series, we have addressed just the first two of these 5 stages. In the second part, we're going to address the preparation and cleaning of that data. We're going to talk about exploring and visualizing the data, and then ultimately how we use these data sets to predict things that are useful for our business. So I hope this was informative for you. If you'd like to learn more, especially in part 2 of this 2-part series on data science and practice, you can check out our other courses at RouteFabric.com. Thank you.